Test 1, 2. I worked so hard on this recital. So I am really excited to be here and to talk to all of you. And so what am I going to talk to you about? Well, human-machine interaction is what I'm going to talk to you about. And specifically, we're going to talk about XR, extended reality, AI, artificial intelligence, semiotics in sound design, and all of those things within the field of electronic music. And in case you didn't know, most of you do already, my name is Dr. Justin Leo Kennedy. All right, so in order to talk about these things, it helps if we review our history. So let's then go back to the Second Industrial Revolution, where my slides were deleted. Wonderful. What happened to all my slides? Well, these things happen. Well, pretend we're in the Second Industrial Revolution, and I will inform you as to what happened. So, in the Second Industrial Revolution, what we can understand is that there were machines like what you heard me perform with today. And what you heard me play today was basically a large industrial machine, like a large machine starting up that you heard there. You also heard a hydraulic machine, so a machine with hydraulics. And then in addition to those things, you heard some pipe sounds. And you also heard me sample the hydraulic sound, which is kind of speaking to the turntable, which is a big, pivotal, important instrument at the time. So all of these inventions were created in the Second Industrial Revolution. Inventions like the turntable, inventions like the radio. Did you hear the gentleman who said, "Welcome to tonight's radio broadcast," at the beginning of that piece? Well, that gentleman was from a 1924 broadcast, right? So radio was big. So now we've got record players, we've got radio, we've got jukeboxes, we've got all kinds of ways that people can listen to music without the musicians actually being there. This created a problem, and the problem it created was called displacement. So if you read the Jacobian at all, it was documented that tens of thousands of workers, musicians, were replaced by machines in the sense that it used to be that there were silent films. You would go to the movies and you would hear live musicians playing music to the movies. But it became possible for people to start recording sound and putting that into the movie theater with the picture. So a lot of musicians were displaced. And there was actually an organization called the American Federation of Musicians that went on strike. There was a big recording strike that even Duke Ellington was a part of. And this strike was created to try to give musicians work because they had been displaced. So the negotiation between the AFM and the record companies was, okay, every time a record is made, every time a record is played, you have got to put money into a pool, and that pool is going to go towards hiring musicians to perform live music somewhere else, like in the park or something like that. So you could see how this is relevant to all of what's going on today, right? What technology would you guess has a possibility of displacing musicians today? Any guesses? Yes. AI, artificial intelligence. So a lot of people's concerns are similar in the sense that AI is a machine, or well, it's code, but it lives within a machine. And you go back to the Second Industrial Revolution, and there are all kinds of concerns at that time period as well as to whether or not people are going to be displaced. The thing is, we really aren't here tonight to talk about a strike, not because I oppose one or support one, but because it's not really my forte. My forte is talking about the way humans interact with machines. So, in that being the case, I want to talk to you about an invention that I admire very much. Who here has heard of the theremin? Okay, yeah, great. Quite a few people. So the theremin was created by Leon Theremin first in 1920, and it was patented in 1928. And there was a very famous musician. Her name was Clara Rockmore. Raise your hand if you know who Clara Rockmore is. Oh, okay, good. I see Dr. Sink in the back. Thank you very much. Much appreciated. So everybody Google Clara Rockmore when you go home. Now, I was going to play it on this laptop. All this high-tech stuff up here, and guess what we forgot to do? I didn't route the audio out of this thing through the system. But I did come I hope you have a little more faith in me than that. I did come prepared enough because I can just pull up the audio on this other computer, and I can show you my screen that way, because you really should hear this wonderful musician named Clara Rockmore. And I know you can't see the screen now, and that's because YouTube is suggesting lo-fi videos and other things I don't want to be part of this lecture. See, look at all those suggestions. This is Clara Rockmore, and this is her playing the theremin. So that's a really beautiful piece from Carnival of the Animals, if you know, by Saint-Saëns. And the reason I wanted to show you that, whoops, let me change the HDMI switcher back. The reason I wanted to show you that is because this is also from that second Industrial Revolution time period. And it inspires me a great deal. The theremin is deeply inspiring to me. And here's why. Clara Rockmore was a virtuoso violinist, and she got tendinitis. She was no longer really going to be able to play violin anymore. And that invention gave us Clara Rockmore, right? We would have been robbed of her musicianship. And so for me, that's a very, very moving thing. That's something that I love about technology, right? Is that technology can change lives and make things better. So with that in mind, we can move back forward and we can talk about really the thesis statement I have for the night. These are my personal philosophies. I'm not standing here trying to tell anybody that you should adopt my philosophies or trying to say that this is how the tech industry or the music business should operate. But what I am trying to say is that these are the philosophies that have guided everything I'm doing tonight, all the research I've done, all the computer programming I've done, all the performances I'll do. So what are my personal philosophies? Well, what is my thesis? My approach to system design and electronic music is guided by the following philosophies. Number one, technological innovations, especially in music, should improve people's lives. And if possible, not at anyone's expense. Now that can be a bit difficult because inevitably new technologies oftentimes have an adverse effect on someone somewhere. But to whatever extent possible, we should try not to have it be at someone's expense. The design, well, let me say it this way. Oh, that's too far ahead. Devices, systems, and electronic musical compositions should be designed to facilitate healthy and harmonious relationships between humans and machines. So the design itself should be healthy. You all have one of these, right? Do you have one of these? A smartphone? Yeah. Would you say you have a healthy relationship with your smartphone? No, you don't. I promise you, you don't. You know who else doesn't? This guy. I don't have a healthy relationship with my smartphone. You know what I do have a healthy relationship with is my toaster. Me and my toaster have a great relationship. I walk into the kitchen, I push the little thing down, it heats up the bread, I eat the bread, and I walk away. I love that design. That is a great design. You know how long the toaster's been around? A while, right? So it's not a bad design whatsoever. It hasn't been replaced, and we have a very good relationship, me and my toaster. That is what I like in technology. I like to use the thing and then be able to walk away. I'm not a huge fan of let's put every single thing that's ever been on a desk and put it all in here. But at the same time, I really admire all of the engineers who gave us multi-touch, which is an incredible accomplishment on the smartphone. So, not knocking people who worked on smartphones, but just giving you an example of the philosophy I carry, which is I would much rather design a toaster, personally. I also like using analog synthesizers very much. You see a couple of them on the desk there. You'll hear me play them later. And one reason I like those, again, I can't check internet on my analog synthesizers. It's not possible, right? So I'm not going to get all distracted. So I really enjoy those things. Another philosophy of mine is that especially cutting-edge technology should be accessible to all people, regardless of physical ability or financial status. Everyone should have a seat at the table, I think. Interactions should be positive that is to say, interactions between humans and machines should be generally positive, or at the very least, free of negativity, right? And if not, if an interaction between a human being and a machine causes a person harm or frustration, something should be changed to prevent that outcome from reoccurring. And that change should not diminish any person. You should not be asking people to reduce themselves down so that the technology now becomes better. And this is actually an idea from Jaron Lanier, and a book that he wrote named You Are Not a Gadget. And he suggests that we have been asking human beings to reduce themselves to fit into the bits and bytes of a computer to make the technology seem more incredible, so to speak. So we talk about a little bit of frustration, right? Sometimes we get frustrated when we use technology. And we talk about how we think about technology and how a lot of times the frustration you're going to have is that whatever device you're using, it's not communicating to you what you need to do in order to fix it. Does that make sense? That's a huge reason people become frustrated with technology. Enter semiotics and sound design. So, Ute Yekash, who writes about product sound design. So product sound design, the sounds of like everyday products you might use in your home, right? So yeah, your microwave maybe, or probably less that, more like a coffee maker, right? A coffee maker with a really beautiful sound to tell you when the coffee is done is gonna make the cup of coffee maybe seem kind of more appealing to you, right? So Ute Yekash writes about those types of things. She writes about product sound design, and she says that sound designers are engineers of communication. The idea, the concept of semiotics, this is not a word everyone knows. Semiotics deals with signs, okay? According to Yekash, people need background knowledge to know what these signs mean. So take a traffic light as an example, right? What does red mean? You know it means stop. Does red actually mean stop? Like, do you think my 1-year-old daughter sees the color red and thinks stop? No. She learns that. She sees the color red and she takes it more like a bull, I think, actually, and charges forward. But the point is, we learn what red means. We learn what green means. We have background knowledge. It's contextual. We live in this society, and so we understand, okay, red means stop, right? So traffic lights are a good example of semiotics within society. The better semiotic understanding a sound designer has, the more effective the sound design can be. So let's take a little demo. Let's take a look. I have a demonstration ready, and I have a few frequencies I wrote down on some paper here. And what we're going to do is I'm going to go ahead and pull up this. And let's make sure that it works. And what I'm going to do is I'm going to enter in some frequencies. Let's start with a simple one. Well, I see signal, as I'm sure you do, but I hear nothing. Let's try that again. There we go. You could hear it? Huzzah! Let's enter in some frequencies, all right? I'm going to tell you the first one. This is from the Conelrad system. A lot of you don't know what that was, but it was like the earliest instance of the emergency broadcast system, basically. And it used a frequency of 1,000 hertz, so pretty piercing and alarming. Is this a nice sound? Want me to keep it on? No. Tells you something, it tells you something's up, right? Something's wrong. And that's actually kind of based on psychoacoustics. Your human ears are sensitive in that frequency range at that decibel level. So there's one for you. Now, I'm not going to tell you the next couple ones. I want you to guess. And if you know what frequencies I'm typing in, and you don't even need to, yeah. If you know these, then you'll know it immediately, is what I'm trying to get at. All right, so let's take a listen to this. This is a sound you probably know. What's that from? Yeah, Amber Alert, or emergency broadcast system back in the day, right? But it's a concern, right? That's a concerning sound. You've learned that that's a concerning sound, okay? How about this one? Musicians in the room. Let's change it to. What do we hear, like, who in the orchestra plays that note? The oboe. That's the note that orchestra's tuned to. It's 440 hertz, A440. It's very significant in our society. I want you to remember that, because we're going to come back to that later when we talk about AI. 440 is very significant to us. We have learned that 440 is what we tune to musically. We have learned that as human beings. Yeah, machine learning? Are you getting the foreshadowing here? Anyways, okay. Let's do another. Here's a good one. Maybe not everyone will recognize it anymore because we all have smartphones, but what's that? Dial tone. See, you know them, right? And I'll point out another example. I'm going to cover this up because I don't want my debit card information to be filmed, but I have a debit card in here in my hand. See the chip? Do you remember when they rolled these out? Do any of you remember that? Debit cards at one point got a chip reader, right? Now you can just tap, right? Does anyone remember when you couldn't just tap? You had to actually insert it and punch the thing? Do you remember that? That sound was annoying, wasn't it? When you'd complete the transaction. Do you remember that? When they first rolled these things out, you may not remember, but when they first rolled out the chip readers, you would put them in the machine, and when you finished the transaction, it would go bam, bam, bam. And the reason that that was so confusing is we associate that sound with a failure, right? So it was poor sound design semiotics, right? And what's important for you to keep in mind is the intent, the purpose of that annoying sound was actually not to tell you the transaction was complete. The designers actually originally wanted that sound to tell you, don't forget you still have a card in here. That's why they did it. But People didn't interpret it that way. They thought it meant that the transaction was a failure. So it annoyed people, and they complained, and they changed it, and now it's like a happy little chime. So you may ask, how do I know all of these things? Pretty obvious. Video games. So anyone who knows me well knows I really love video game music, especially older video game music. Oh, goodness. And what I'm going to do now is I'm going to load, I'll play some music, but first I'm going to load some stuff here. Just give me a sec to load things. Oh, we love technology at this school. Everybody says, Dr. Kennedy, Dr. Kennedy. There's nothing better than when things don't work. All right, I got to be very careful here. I think I can trigger these sounds without making the whole track trigger, I hope. Well, let's hope so. But I'm just going to play some sounds here. And we're going to have a little bit of fun. All right. So I ask you, and just shout out the answer, okay? When you hear these two sounds in combination, what's happened on the screen? Something exploded. What happened before? Yeah, either a jump or like a shot, right? Something, but probably a jump, right? And then you like hit something and it explodes. Now, if I do these sounds in combination, what's this? You got something. Oh, man alive. My research is going good. Yes. Yes, power up. In fact, my colleague, Dr. Gildori, and I wrote a paper. That's part of what is being presented here. And the paper we wrote was called 8-bit dynamic notification sounds. And we talked a lot about semiotics, and one of the sounds we talked about that I modeled right here was power up, and was also a meter charge. To me, that sounds like a meter that's not totally filled up. So you do, and then when you get enough of those little collections, what's that probably mean? Yeah, like maybe, like probably an extra life or some kind of like something, like extra something, right? So now these aren't like hard and fast. You don't know exactly what all of those are, but you get the basic idea, right? Like you have a basic understanding. Okay, like I can follow that. So the composition you'll hear me play some sound effects in there, and. But first, I'm going to play, there's two movements for this particular composition, and I'm going to play first like a title screen type of a sound, like if you were to turn on a video game in the 1980s, and the title comes across the screen, and it's really low quality. And then the second movement I'm going to play will be this one, and that will be more like if you were playing the stage, and you'll hear the sound effects in there. So let me load the right movement. Do, 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 do. And because we've got so much sound from so many sources in this concert, I definitely want it. I definitely want Professor King, who's back there. See? I knew there'd be a problem. It's okay. Thanks to my good friend Zach Shatley, I know exactly why that happened. So thank you, Zach. So I want to just do a quick little sound check. Professor King, if you just let me know if it sounds okay. Oh, that's way too quiet, isn't it? Here, I will turn this up a little bit. Do-do-do-do. This is why I have a mixer. There we go. Okay, so I'll play like a little title screen thing, and I'll pause for a second, and then I will play right after that a stage that uses the sound effects. So here we go. Oh, my water's all the way over here. So hooray for Mega Man. You can tell I played that a lot, probably. So we just did this. We don't need to do it now. So when we talk about video games and we put that in the context of, well, now how does that connect to augmented reality? How does that connect to virtual reality? How does that connect to artificial intelligence? In more ways than a lot of people know, actually. The very first VR company was VPL. And it was created by the people who made the Power Glove. The one thing that's really bugging me here, though, is my slides didn't. There. How dare you? They were not displaying right, and I worked too hard on this for them not to display right. So the Power Glove. Does anyone know what the Power Glove is? Did you ever see it? Yeah. It was a really cool idea. And the glove that was originally created, it was created by Thomas Zimmerman and Jaron Lanier, the gentleman I talked about earlier, who wrote You Are Not a Gadget, who's obviously had a big influence on my work. The Power Glove was created by these two, and it was originally a glove that cost a lot of money to manufacture. So when Mattel was interested in it, they had to find ways to cut down costs, right? And so the sensors that they ended up using and the design they ended up using maybe wasn't quite as fluid. But the main point is this glove was one of the earliest mass manufactured products for virtual reality. And the very first company for virtual reality was Thomas Zimmerman and Jaron Lanier's company, VPL. And a really cool video game that was played was called Super Glove Ball. Anyways, I just liked that game a lot, so I thought I would mention it. So we should talk a little bit about these AR, VR, MR, etc. We should talk about those things and what they mean. Virtual reality would be if I were, here I'll do something kind of fun. If I were to take my beret, just imagine this is a visor, okay? There, it kind of looks like a visor now, right? Yeah? Yay. Okay, so if I were to take this and it's black, it's opaque, right? You can't see anything. If I just did this, that's virtual reality now if there was something displayed in there. In other words, you can't see anything around you, only what's in the virtual world, right? That's virtual reality. Augmented reality, you already understand very well if you've played Pokemon Go. That's augmented reality. Augmented reality, Pokemon Go, for those maybe not familiar, is you get out your phone, you walk to random locations, and on your phone, up pops a Pokemon that you can collect. And it's fun. You can meet other people that way. I would say that it's probably not a good idea to wander into traffic like some people did. But nevertheless, that is an example of augmented reality. MR, mixed reality, is like if we combine these things. All of this is exhausting, keeping track of all these acronyms. The tech industry is one of many acronyms. And what I will tell you is that really what you want to know is the phrase XR. And XR just encompasses all of these, extended reality. I almost said extended techniques because I teach so many orchestration classes here. Extended reality. And so, well, we had a hand gesture tracking with the Power Glove, well, essentially a hand gesture tracker. But what about eye tracking? What about face tracking? Now, again, you might say, well, but what's that got to do with games? Everything. I have an eye tracker up there that I'm going to use, and it was made by Tobii, Tobii, I believe, and it was made specifically for video games. That's its purpose. But it can be used for other things. Enter this young man. Again, we don't have sound here, so I'll describe the project and then I'll play it on this other computer. But Joel Bueno and the iHarp. iHarp is a company that I collaborate with a lot. I'll be using their software tonight. And iHarp is responsible for creating the world's first gaze-based musical instrument. So you look at different notes on the screen, and it plays those notes when you look at them. That's how that works. It's very exciting. And again, my colleague, Dr. Gil Dorey, he is the creative director at iHarp. So when I use iHarp tonight, I just want it to be really clear. I didn't develop that software. In fact, I haven't developed any of the software that I'm using. I have written code, but just FYI, there is a difference between a software developer and a computer programmer. Now, a software developer develops software applications we can use, right? But a computer programmer writes code. And so software developers are inherently computer programmers, but the inverse is not true. So the reason I bring that up is because I didn't want to take credit for something that isn't mine, and I want you all to know that iHarp is an incredible company, and I support them very much. And I had the chance to work with Joel Bueno. He is kind of the Clara Rockmore of the iHarp, I would say. And one of the reasons I showed you Clara Rockmore is, remember, she had tendinitis, right? She had tendinitis, and she wouldn't have been able to continue to play music if not for that invention. The theremin gave us Clara Rockmore, and the iHarp gives us Joel Bueno, who wouldn't be able to play a musical instrument any other way, and he is a phenomenal musician. I had the opportunity to write a composition for him, and so what we did is we found some really cool old analog synthesizers at the Phonos Foundation in Barcelona, Spain. And I wrote a piece of music and did the synthesis for it. And my colleague Gil Dorey and I wrote a little code to be able to make things connect. And Joel played it, and he did an amazing job. He's a phenomenal musician. So I'm excited to share his work with you really quickly. I won't play the entire clip. But one of the things I really wanted to make sure I did is I wanted to make sure you are able to see his face and how happy he was. If I can spell. He was also just on like Spain's Got Talent, so that's really cool. I was very happy for him. So this is a recording that we did. Let me switch it so I can make sure that you can see it. I'll probably skip ahead in this video. It's 6 minutes. I don't want to just show you a 6-minute video. But I just want you to take a look and just see this young man performing music with his eyes. It's really inspiring. So that's the main melody, and you'll notice that there's kind of a musical score. Now this is iHarp's innovation, not my own. I wrote this piece of music, and my colleague Gil Dorey said, give me that piece of music and I will put it into, you students are gonna like this, into MuseScore. Ha-ha! Because iHarp can take a MuseScore file if you do this, 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 and this to it and write these lines of codes and da-da-da-da. It was really exciting. So I had to write it in MuseScore. So I wrote the piece of music in MuseScore and I gave it to my colleague. And what happens is the software, iHarp, it puts up like a little like preview of the note that you're going to be playing, and it pulses in the time of the music, at the tempo of the music. And so the note that is pressed down here, this brown one here that's pressed down, that's the note that you're playing, but the little circle is telling you the note you're going to go to. So that's how that score works. And I thought that's really cool, that's very exciting, but I don't wanna just like make Joel like have to stick to doing exactly what I write the whole time. Let's just let him cut loose. Let's let him have the joy of analog synthesizers. I really love analog synthesizers because you can get lost in the sound, and I kind of call it a sound bath. Now, people here may think that you could get lost in the sound of any instrument, and that's true, but there's something special about a synthesizer when you walk into a room and you're playing it, and then you don't even know 6 hours has passed, and you walk outside. And anyone who has used extensive amounts of analog synthesizers will tell you the time goes by like that. It goes by very quickly. So I wanted to give Joel the chance to be able to just mess around with synths and to sort of get bathed in the sound, and it was so delightful. If you can see his face, it's a little bit tough to see in here, but he just has the biggest smile on his face when he starts being able to make crazy siren sounds. So that was basically just giving him the chance to be able to like make crazy siren sounds. We programmed the MIDI output of the iHarp to be able to do crazy things on the synthesizer. And afterwards, after we did the take, we wanted to do 3 takes, and I asked Joel if he wanted to do another, and he was like really excited, like, oh boy. So synthesizers are a great deal of fun. And using eye tracking software to make music is also a great deal of fun. So we now start to get into the last topic I have to talk to you about tonight, and that is artificial intelligence. This has consumed my life. I have done nothing but read about AI the last, I don't know, year. It's been all-consuming. And I wanted to use artificial intelligence, but it is the center for controversy right now, as you may or may not know. One of the things that is at the heart of controversy is that AI is using existing musical works and learning how they work and then creating something very similar. Have people heard this? Have you heard about this? I'm not denouncing that or saying it's a bad thing. I'm not saying it's a good thing. It just is a thing. And people's opinions are okay with me, but my goal in using AI, and I will perform with AI tonight, my goals were the following: to co-compose and co-perform a new piece of interactive electronic music in real time with a machine learning AI where the following conditions are satisfied. Number 1, no particular composer's work is used as a learning model, and I will state why. And the reason why is because I don't want to accidentally violate someone's music, accidentally take someone's music from them, right? Number 2, no specific genre is used as a learning model. And I'll state why for that as well. Well, I didn't want to accidentally like stereotype a whole genre, right? I didn't want to do that by mistake. Number 3, this condition says the AI cannot complete its musical expression without human input. So you cannot hear what the AI has to say unless I approve it, unless I let it through. And I'll tell you how that system works in a minute, and I'll show you. It'll be fun. Next condition is that the human and the AI should influence one another's decisions and actions. They should interact with one another and enhance one another's output. And then finally, I wanted to challenge myself to perform only using face and eye tracking. I achieved that goal except for one thing that I didn't automate on there, so you will see me twist a knob once, but it's only, well, twice. But it's only 2 times, okay? Like, I couldn't automate it. Yes, I was coding a very long time the last couple weeks. So those were my goals. And what did I use? Well, I am using OpenAI. Who is OpenAI? Does anyone know? What software do they make? It's up there on the board. They make ChatGPT, right? So I'm using OpenAI's Text DaVinci-03, which is a machine learning model with a transformer architecture. There are convolution neural networks. There are recursion neural networks, and there are transformer architectures. So transformer architectures focus on what's called self-attention mechanisms, but I won't get into all that. Essentially, it's what ChatGPT 3 used. There you go. As one might assume, it generates text to a prompt, so it's not designed for music. And that was both a blessing and a that was a blessing and a curse, and it was sort of a blessing in disguise. And my prompts asked DaVinci 3 to write out chords. So I'm going to just talk to you a little bit about some early experiments. No, I'm not going to play the early experiments because they're bad, okay? I'm not going to do that. But early experiments, I'm just going to chat to you about some of them. So what I first tried doing was saying, write a chord progression that sounds pleasant or dark or sad. And it would give me these results that felt kind of like a music theory textbook, right? It would give me a lot of predictable responses. And also, when I did this, I thought, well, there's nothing really stopping me from just writing an algorithm that abides by the rules of music theory, in which case I don't need AI. Does that make sense? I could just write an algorithm and it could just execute it, almost like rolling the dice. This is called stochastic, like a stochastic model. And you could do all kinds of interesting things with that. Mozart had a dice game. So what I ended up doing was I ended up thinking, what about more complex musical terminology? Let's try that. So I gave ChatGPT, I said, spell G7 sharp 5 sharp 9. You should try it sometime. Maybe it's gotten better and it's learned how to do it. But when I asked it to do it, it totally spelled the wrong chord. And it also analyzed the music from the Avengers incorrectly. So I was concerned about those things. And so what I ended up deciding to do was I had to evaluate whether or not my method was a good method. And I concluded that DaVinci 3 just did not seem too adept at interpreting prompts with aesthetic verbiage and translating that aesthetic verbiage into a chord progression. So I took a different approach, and what I thought is, what do computers typically do really well? And I thought, calculation. They're very good at calculating things. They've always been good at calculating things. And so my new prompt was not to write a sad chord progression, etc. I asked ChatGPT, output 3 frequencies that are harmonious. And I used the word harmonious very deliberately because it carries a mathematical meaning, but it carries an aesthetic meaning as well. So really I learned that the problem was my prompt. I wasn't asking for something that would really generate the results I wanted. Really interesting, DaVinci ended up choosing a lot of chords that were just chords. Do you know what I mean? Like just intonation. So it would give a lot of chords that were perfectly in tuned and were not part of the equal temperament scale. So there are black keys and white keys on a piano, right? You've seen them. But there are notes in between all of those, right? And we may wish to get to some of those. And when you go into using just intonation, that accesses notes in between those. It's like a perfect tuning. A just chord is like a perfectly tuned chord. It also chose the key on its own. It chose, well, at least it chose a tonal center. It always chooses A minor, but it did choose a different key, which will be very bad for me if it does that tonight, because I'm prepared to play in A minor. So, but I'm pretty sure it's going to choose A minor. And then it also, really interestingly, it started without me asking it to. When I would re-trigger the prompt over and over, it would write a chord progression. So I was only asking for a chord, 3 harmonious frequencies. So 220, 330, 440, right? A, E, A, right? And I would re-trigger the prompt, and then it would give me a C major chord. And I would retrigger the prompt, and it would give me a D minor chord, and retrigger it, and then it would eventually come back to A, E, A. So it started writing the chord progression without being asked to, just because I kept retriggering. And this is something that we know can happen with a transformer, model architecture, and artificial intelligence, because they're good at long-term processes. They can remember earlier in the conversation. So for me, this felt very much alive. All of the data that was happening felt very much alive. And I thought, well, then what I want to do is I want to take the data that DaVinci is giving me, and I'm going to send that data into a Moog analog synthesizer. And so kind of in effect, giving the synthesizer a body, right? And then I thought, well, okay, thinking about bodies, if I'm going to bring part of the AI into the physical world, then I should go into the digital world, and that's where I thought of using face tracking, right, and performing that way. So now we inhabit one another's spaces. So let's look at my system. So what you can see up here is that the smartphone is communicating wirelessly to the MacBook, and then I wrote code in Python that will see when I open my mouth, and it will trigger the prompt to give me 3 notes, 3 frequencies. And then there's software called Max for Live, and I took the frequencies given to me by the artificial intelligence, and I converted those frequencies to voltage, so that way it could play an analog synthesizer. Separately, you will see eye tracking software, the iHarp, and that goes to a Moog Mother 32 synthesizer. So then I can play with my eyes and my mouth, kind of like if I was a pianist. I have a right hand, and that's playing a melody, and I have a left hand, and that's playing chords. So that's kind of how my mouth and my eyes were in my mind. Let's take a quick demonstration. And I'll talk through it, and then I will play this thing, and then conclude. So, let me make sure I do not broadcast my IP address. It's not up there, right? Okay. All right, good. Let me minimize Python. And I just really want to be careful. I really don't want to put that up. That would be very embarrassing. And, all right, so let me change the view. Okay, good. Now, you can see my face up there. Whoa, see, I opened my mouth. This is, I did not think about this part. I'm going to cover that. I practiced so many things, but not that. Okay. So what you're looking at this is the smartphone. This is, I've got it coming into the computer here so that way you can see what I'm doing. And as you can see, I'm going to stop talking after this so that you can see it, but it is face tracking software. So let's look at my face. And that face tracking software, the way it works, everybody, is I've set it up so that when I open my mouth, it plays a chord. But I wasn't always happy with the chords ChatGPT would write. Once in a while, it would give me one I didn't like. And sometimes it gets into a bad rut, and it just gives me a bunch of bad ones in a row, and the piece really goes off the rails. So I discovered that I could do like a sneer with my nose, like scrunch my nose up, and the computer could see that I was doing it. And so what I do is when I sneer, it loads the next chord, and I can read it to see if I approve of it. And if I don't approve of it, I'll sneer again to go to the next one. But it loads the chord in there, and in order for it to be heard, I have to make a sound. Does that make sense? Like, I have to open my mouth to make it sound. So the goals that I stated earlier, right? The AI cannot be heard without me doing that. So I'll demonstrate that really quickly for you. So it feels a little goofy to do it, but it works, okay? And that's the point. So that's the first thing that I do with my face. There's another thing I do with my face that's really ridiculous that I'm not going to demonstrate because things could go way off the wall if I do. I'll demonstrate it. I think it'll be okay. I think it'll be okay. This, by the way, I was like super all professional earlier in this lecture, but this is what my students actually deal with. Just so you know, any faculty in the room, this is how I actually am in the classroom. Like, yeah, I'm not gonna do it. Oh, okay, I'll do it. I'll do it anyway. So the next thing that I wanted to do is I didn't want to just be able to arpeggiate chords and that's it, and I can never do anything else. I wanted to be able to trigger other things, right? I basically wanted like a button. When you use a synthesizer or when you use stuff around your house, you have buttons that you can push and they do different things. And I basically wished I had like a button to be able to make this whole system that I've designed here do something else other than just roll a chord, right? So I thought, okay, well, I need to do something and I need to do a facial gesture that I would never ordinarily do. And so I thought, I'll like smile just the right side of my cheek. And that did work, but the problem is sometimes I'd get nervous and I would laugh and I would trigger it. So I created a system where it looks for me to smile with my right cheek, but then it looks for me to like pucker up like a kiss, like that. And if I do those two things, one after another, then it'll work. So you have to do the right side of your cheek smile and the pucker combo in order to press the button. So, so I will demonstrate this now. To see it? I'll do it again. Look right here. Okay. Don't ruin the piece. They haven't heard it yet. All right, so that's how that works. On this other computer, I'm going to have to cover this up. I really should have got like a little black, but I don't know, I kind of find it amusing that I just throw a piece of paper over it. So on this other computer, on my PC, I am going to open iHarp. And iHarp is a lot easier to understand. I look at the note and it plays the note. So great UI design. Oh, shoot. Technical problems. Womp, 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 womp. I'm glad I got a laugh from the film crew. I heard them back there. All right. Come on, work. Ah! But wrong octave. Cool, huh? So you just look at it, you look at the note you want, and then it happens. It's like magic. How did they do it? So I will actually attempt to play this thing. It hasn't crashed since Sunday. So I think it'll turn out okay. And then I'm going to go home and sleep for 4 days. Actually, I have to teach tomorrow, but see you at 9:30. All right. I'm going to try to play this. I can't talk anymore because if I do, I'm going to set this thing off. So let me restart, re-trigger. Everything's at 0. Oh, you know what I didn't do, musicians? Haha. I didn't tune it. Let me check the tuning. Oh, see, it's a little bit, you can see it's a little bit, oh no. It's got to be a root, it's got to be at 220. This is the problem with using Analog Live. All I talked about was how great it is, but it also goes really out of tune. And I thought this might happen, and I have a really great anecdote to tell you while I try to tune it if it goes on too long. But hopefully it doesn't. Look at this, look at how ridiculous this is. All right, so while I try to tune this, I wanted to share one early experiment I did with you. I did want to toy with the idea of having ChatGPT talk to you, kind of like Hello World, like Apple, the Macintosh, and everything. So I had ChatGPT simulate an argument or describe an argument between Socrates and Winnie the Pooh. So I will now play this for you while I attempt to tune for your amusement.
Socrates becomes angry with Winnie the Pooh when they are discussing philosophy. Socrates is trying to explain the concept of virtue and applies it to a complex ethical conundrum. Winnie the Pooh, who is not educated in these matters, keeps repeating, "Oh bother," and fails to follow Socrates' logic or understand his point. Frustrated by the lack of comprehension, Socrates grows angry and eventually storms out of the discussion.
There you go. I'm a college professor. All right. Okay. Almost done, I swear. Well, a few glitches, but no crashes. All right, so I was just going to open it up briefly if anyone has any questions. Did anyone want to ask any questions? We do have a mic, but it's all the way up here. You could just shout and I could probably hear you. Did anyone want to ask anything? It's okay if you don't. Oh, look, we have a portable mic.
So for the eye tracking one, how did you program the different rhythms? Because some were like more staccato and some were more elongated.
Just a lot of practice.
I see.
So you look at the note, and when you look outside of the circle, it turns the note off. If you look inside of the circle, it keeps the note on. So just like look at it, look away, look at it, look away, look at it, look away. But the thing I didn't count on is how hard it is to keep the rest of my face from triggering anything while I do that. So.
And how did you look at the new chords while doing that?
Oh, good. So someone finally figured it out, and I have to admit to cheating in that portion. So the AI chose the chords anytime I wasn't playing the iHarp. But last night, I tried running through this. Last night / this morning, I tried running through this, and I had that same problem. So I did a screen capture of chord progressions that AI wrote, and then I programmed those in so it would just load a chord that was predictable that I could rely on. So there's a small portion of pre-composed music in there. The AI composed it, but it is pre-composed because, yes, I also tried to look at 2 screens at once and was unable to without severe eye strain. So good question. You figured out the little cheat. Good job.
Which part of the preparing for this was the most difficult? Learning how to play the piece, or the preparation it took to get all the parts working to where you could play it?
Easily the hardest part was taking the frequency data and converting that to control voltage. That was easily the hardest part, because the way synthesizers work is control voltage for most synths, with a few exceptions, is 1 volt per octave. But the thing is, every synthesizer is different. If it's an analog synth, it's worn out by time. Circuits wear out by time. Does anyone have devices that don't work as well as when you first bought them? Haha, lo and behold, right, circuits, they wear out. So what happens is, when I was like, I'll give you a great example. 1 volt per octave should mean that if I have A220 on the nose, like perfectly tuned A220, I should input 1 volt and it should give me an A440, right? Well, I had to scale for my particular synthesizer, so I had to put 1.0026 volts in order to get that note. And I had to do that for the entire frequency range between 220 hertz and 880 hertz. I was going to go up higher, and I gave up. So that was easily the hardest part, was scaling all of that, like by far. And then also trying to understand how the AI worked and how it could actually write a chord progression I liked without forcing it to write a chord progression the same way every time, except for the time where I had to look at another screen because I couldn't look at 2 screens at once. Other questions? This is fun. This is the most fun I've had in a while, actually, since Halloween when I dressed up in my Star Trek outfit.
Where were you?
Yeah, advising day.
Hi. So I was curious, how susceptible to like a major mess up or a failure in the design of it in a piece?
What were the, like, are you asking what the chances were?
Yeah, like how often would this mess up?
Yeah. How often did it crash? A lot. Tonight, I felt like I got everything solid enough because I did what's called feature cutting. Does anyone know what feature cutting is? In computer programming, when you're creating something and you want to add features, you know, like, let's say your smartphone, you can swipe to the side and it's like turning a page. Well, that's a feature, right? But when you start getting real close to a deadline, you feature cut. And the reason you feature cut is you are trying to create stability. So I spent a lot of time creating stability for this in the last week, and I was relatively sure it wouldn't crash. I had a 4th piece I wanted to do tonight, and I had to cut it because, you know, at the wee hours of the morning, I couldn't get it to stop crashing, and I just had to concentrate on making this one really good. And then the frustrating part is, you know, you also have to write the composition, and you also have to do the mix, and you also have to perform it. So when you combine all of those things, it gets stressful. But I think there was a high probability that it would fail a week ago. So we've avoided it.
Thank you.
Anybody else? John?
Howdy. When you get to the facial gesture with the side smile and the puckering up,
Yes.
was that also automated with AI, or is that like pre-programmed arpeggiations that you had put in?
Oh, good question. The arpeggiations, here's how it worked. The smile and the pucker, that is happening through augmented reality, right? Because I'm using the phone, and the phone is what's sending that data to the computer. So it's that data, it's that face tracking data going into the computer, and then I told the computer, when you see a smile on the right side of my face, put a 1, and then when you see me pucker, put another 1, and if the sum of that equals 2, then trigger the next thing. And what it triggered was not an arpeggiation in the sense that it was pre-composed, but it triggered what in synthesis we call an arpeggiator. So there are 3 notes, and it would just play through whatever 3 notes were there. But the AI continued to choose the chords until the section where I played iHarp, in which case that was pre-composed by the AI, but still pre-composed.
Excuse me, I'll scoot by you.
Thank you for doing this, Tanner.
Yeah, yeah.
How long, total was this project?
I don't know. I lost track over the. I first performed with face and eye tracking software in here in 2021 and learned from a lot of those mistakes. The biggest mistake I learned from was I was triggering things in that performance with face tracking as well, but I was just using one facial gesture and it would fire randomly. Because sometimes data drops, right? Like you use your phone and you're looking something up on the internet, and then all of a sudden, like you can't see it anymore, right? Like because, the Wi-Fi dropped or the data dropped, or you've loaded a page certainly, right? And it doesn't load right. Or you've used Finale. That's a really great music notation joke for anyone who knows that software. But the point I'm making is that the process took from 2021 until now, but I hadn't really integrated the AI until this year because I didn't understand it well enough. And I'm still trying to understand AI better and better all the time because it's here. It's the cultural zeitgeist right now. What time do we have? I don't want to keep people too crazy late. And this said an hour and a half, right on the money. So let's just do one more question if anyone has one.
Yeah, with that timeline in mind, what further refinements or grander vision do you have for this project?
Yeah, I would like to create a system where I would like to see very much, I'd like to do a lot of the kind of stuff iHarp is doing and just integrate AI into that to make it easier, right? So maybe the artificial intelligence, I'll give you an example. You saw Joel Bueno play, but he's not able to control like the levels of a mix, right? He's not able to, I don't know, plug in cables or whatever. Like I would like to be able to create a whole like music system that's like AI is not actually intelligence, just FYI. It's not like an actual sentient being at this point. I would like to integrate, I should say, machine learning into all of this. And I don't know, I would like to create a product or work with someone on creating a product that would be inexpensive and accessible to people. And I have some ideas in mind, but I don't have any non-disclosure agreements on me for you to sign right now. So, but I have ideas written down in my journal for what I want to build. I just, haven't built it yet. Well, okay. Thanks everyone for coming to this weird, wild time.